This video provides an introduction to exponential functions. An exponential function is a function of the form f of x equals b to the x, where b is greater than 0 but not equal to 1. b is called the base of the exponential function. So basically, an exponential function is going to have the variable in the exponent. That variable b is going to be some kind of number. Let's practice evaluating exponential functions for a given x value. Let's evaluate f of x equals 4 to the x at x equal to 1.2. So this is the same as 4 raised to the 1.2 power, and we're just going to plug this into our calculator and then round to the nearest hundredth. When we do this, we get 5.28. Next, let's evaluate g of x equals 6 to the 3 minus x power when x is equal to 1.2. G of 1.2, that's going to be equal to 6 raised to the 3 minus 1.2 power. If you want to put this all in the calculator at once, be sure that you have parentheses around that 3 minus 1.2 to indicate to your calculator that whole thing is in the exponent. Personally, I'd probably subtract those just so it's easier to type in my calculator and I'm not likely to make a mistake. So this is the same as 6 raised to the 1.8 power. Typing it into our calculator and rounding to the nearest hundredth, we get 25.16. Exponential functions and their graphs have several general properties. The first property is that the domain is all real numbers. Hopefully this makes sense. You've had lots of different numbers in exponents before, and it's never been a problem. We've had positive numbers, negative numbers, zero, fractions. There's never been a restriction on the number in an exponent, and there never will be. So our domain, all real numbers. The range, however, is only the positive numbers, 0 to infinity. Our base number b is defined to be strictly greater than 0 and not equal to 1. So this means that our base is a positive number. If you take a positive number and raise it to any power, you're still going to have a positive number. Therefore, our range is only positive numbers. The graphs of these exponential functions do not have an x-intercept. Since the range is only positive numbers and the x-intercept happens when y is equal to 0, this is never going to happen. In fact, there's a horizontal asymptote on the y-axis of these exponential functions. All exponential functions do have a y-intercept of 0, 1. Again, this should make sense to us since we're taking our base and raising it to the 0 power. We have an exponent rule that says anything raised to the 0 power is equal to 1. That's how we get the y-intercept of 0, 1. When b is greater than 1, the graph will rise from left to right. So it's going to look something like this. But if your base is some number between 0 and 1, the graph will fall from left to right. It's going to look something like this. And lastly, all exponential functions are 1 to 1. We can see just by those little graphs I drew that they pass both the horizontal and vertical line tests. We have a special number when we start talking about exponential functions. The number e is called the natural base. E is an irrational number like pi that shows up all over in math and in nature. So e is approximately 2.72. The exponential function with base e, which is written f of x equals e to the x, is called the natural exponential function. This is such a popular function that you even have an e to the x button on your calculator. As I mentioned, e is an irrational number, which means it's a decimal that goes on forever, which is why we approximate it to be 2.72. And since f of x equals e to the x is simply an exponential function, all the properties that we discussed for exponential functions apply to the natural exponential function as well.